Hi, I just wanted to share with you guys on the demo that I'm working on for Progress Next. I didn't get a chance to present this earlier as I had to drop off. This is going to be in a session named Building Event-Driven Architectures using OpenEdge CDC. The idea is to talk about what is CDC, why CDC, how CDC can be used in various architectures, and how CDC can be configured in OpenEdge database. The one that we are focused on for this session is using CDC to build event-driven and streaming architectures. In the demo, the main components are Progress OpenEdge, Apache Kafka, Apache Spark, and Amazon Redshift. So I'll be going through 3 use cases while going through this architecture. The first one is uh, alerts on events. The second one is real-time data processing and data visualization. And the third one is data replication to data warehouses like Amazon Redshift. So let's talk about the first use case. Let's say we have a manufacturing company that wants to send out alerts to its customers on new orders. In this case, let's assume that manufacturing company has a very simple database with tables called products, orders, order details, and customers. And they have enabled change data capture on orders and order details. So what's going to happen is I'm going to insert a couple of records into the orders tables, and these records will be captured by the change data capture tables and will be written into Apache Kafka. The way Apache Kafka reads those messages from those change data capture tables is using a component called Kafka JDBC Connect, which uses Data Direct OpenEdge JDBC driver. Once the records are in Kafka topics, I have written a custom Kafka consumer that listens to these topics, and whenever there's a new order, it will send out an alert to the customer. So let me show that to you in action. I'm going to use my SQL editor for most of the demo because I really don't have an UI. Let me start my Kafka consumer, which listens to those topics. So my Kafka consumer is on, and give me a second. Let me readjust this window. I'm going to insert a couple of an order, not a couple of orders. So what happens is, as soon as I insert the data into OpenEdge orders table and order details table, those are getting captured by the change data capture tables and are being immediately read into Apache Kafka topics. Once it's there, my Kafka consumer has read those messages and sent me an email. As you can see, I already got the email. So what the Apache Kafka consumer does is it relies on the CDC metadata information. Say it checks whether the record is an insert or update or a delete, and if it's an insert, it assumes that it's a new order and it will send a new alert to the customer saying that a order is placed. So that's what happens in background. So let me go ahead and create another new order. Just want to show you another example. So I have an order created. My consumer has already detected that new order and is in the process of sending an email, and the email is sent. In a couple of seconds, I should be seeing the notification from the Kafka consumer. I already got it on my mobile. Yeah, it's here. As you can see, it's really fast. Let's talk about the second use case. So let's say the manufacturing company has a lot of orders coming in every second, and they want to analyze the data to detect any patterns or anomalies. In this case, uh, I'm using Apache Spark to read the Kafka topics into my Spark engine using a Spark streaming API. What the Spark streaming API does is it will convert a stream of data into batches of data. In my case, I have set the batch size to be 20 seconds. So every 20 seconds, it collects the data and processes them and creates a visualization. So if data comes, all the data that comes after it, it will be in the next batch and it will be processed as soon as this one is completed. So let me show you that in demo. Uh, so I'm going to create a bunch of orders into the existing order. So let me start my Scala program, which will run Apache Spark engine locally on my machine. All right, my Spark engine is up and running, and I'm inserting a couple of records into OpenEdge database. These records will be captured by change data capture tables written into Kafka, and my Scala program with the help of Spark Streaming API will read those messages in batches of 20 seconds, processes them, and gives out an visualization. So after 20 seconds, I should see a new visualization. So this is the visualization that we are currently seeing is for the records that I've created for the alerts demo, and the visualization that we are seeing right now is for the records that I've just created. So let me go ahead and create uh, another batch of records to see it in real time. So again, written into OpenEdge, tracked in change data capture table, written into Kafka. Scala reads them, processes them with the help of Spark engine, and generates a visualization. Give it a few seconds, and we should be having a new visualization since I have set it to 20 seconds. So there's like 20 to 30 seconds of gap between each visualization. It should be already, yeah, it's here. So you can see I got a new visualization on the new record. Effectively, this can be used to detect any anomalies in the stream or maybe connect to data RPM to detect anomalies. So this is really awesome. I wanted to show this visualizations in a single frame, but there isn't a really good solution to really do that in the market. I was hoping Apache Zeppelin would do that, but it's really not working with the Spark Streaming API. So I had to write a custom program that generates a new frame for every 20 seconds of data. So anyway, that's a different problem for different time. And the third use case is data replication. Say the manufacturing company wants to move to the cloud, move the data to the cloud for big data analysis or analytics or audit. They can use the change data capture metadata information to replicate the data from OpenEdge to Redshift in real time. Let me show that to you in action. So I'm going to start my Kafka consumer that replicates the data. Okay, I have it already started. And as you can see from my Kafka consumer, it has already found a couple of orders and already inserted them into Redshift. So if I go to Redshift, it's already there. These are the records that I have created previously for the last two use cases, and these already got inserted. So let me show this to you how this works in real time. And my Kafka consumer is still running, and I'm going to insert 3 new records, and let's see how it goes. So I have inserted 3 new records. As you can see, it has detected those changes and inserted those records into Redshift. Let's go to Redshift and query it. We have 3 new records. Let's update a record. I want to update the address for a order to 1 Progress Avenue, Bedford and USA. I'm going to do that. It's done. And if you can see, the update has been done already. And if I go back to Redshift, you can see the record over here, 1 Progress Avenue, Bedford. And if you have noticed, I'm also getting notifications from my Kafka consumer that is basically programmed to send out alerts in for new orders. So you can see it over here. And let me go ahead and delete a record. Delete it. Done. And my consumer has already deleted it. Let me go to Redshift. It's gone. As you can see, it's really fast. It happens in less than 2 seconds. And yeah, it's awesome. So if you think about Kafka consumers, they are like plug and play microservices. Even if one of them crashes or or stops for some reason, the other consumers are not really affected. And once you fix that consumer and restart it, it will start over from where it left off. So it also has a fault tolerance, and it's also highly scalable. Say your consumer is not being able to handle lots of data. You can attach another consumer and create another partition in a topic, and you can scale it as much as you want. It's really awesome. So this is basically that I would be going through in the demo, and I would really love to hear your feedback and thoughts about this demo. And one other thing that I was thinking was bringing in hybrid data pipeline into this picture. Say I wanted to connect hybrid data pipeline to Redshift so that we can enable analytics on Redshift using hybrid data pipeline, OData API, or the ODBC or JDBC drivers. Maybe if the Redshift is residing in the virtual private network where it's not really accessible from public, we can use hybrid data pipeline to do that. So let me know what you think about it, and thank you very much for listening in.